Hey guys, welcome back to the channel Partly Patsala. In this video, we are going to discuss Coulomb's law of class 12. Electrostatics is the branch of physics in which we study the properties exhibited by the charges at rest. In electrostatics, as we know that two charges either attract each other or repel each other. It means there is a force between the two charges. Sometimes this force is attractive in nature and sometimes this force repulsive in nature. So how much force is acting between two charges? That has been given by Coulomb. In this video, we are going to discuss what is Coulomb's law and how can we find the force between two charges. Coulomb's law states that force between two charges is directly proportional to the product of the two charges and is inversely proportional to the square of the distance between the two charges. Also, the force acts along the line joining the center of the two charges. Here two charges Q1 and Q2 are separated by a distance R, and let Q1 and Q2 are two charges separated by a distance R. Let be the force between them. Then Coulomb's law says that F is directly proportional to 1, 2 and R is kept constant. Also, this force is inversely proportional to a square of the distance. So R is the distance and it is inversely proportional. So here we don't have the sign of inversely proportional. So we are using sign of proportionality. Instead of taking direct relation, this is reciprocal of a square of distance. It means it is inversely proportional. Q1 and Q2 kept same. By theory of joint variation, if we combine these two relations, we get combining above get directly proportional and Q2 by square. This is Coulomb's law. Still this doesn't say anything. Force is acting between the two charges. This is directly proportional Q1 Q2 by R square. We are going to replace this proportionality. We are going to replace this proportionality. We will have to take a constant. We will take a constant. So here K Q1 Q2 by R square, where K is proportionality constant, and its value depends on choice of unit in which we are calculating force. Easiest unit of charge is ESU and its full form is electrostatic unit. One electrostatic unit of charge is defined to be that charge which exerts one dyne force if they are separated by 1 centimeter. I am explaining here on the board in CGS unit. So suppose two charges are there. One charge is 1 SU and other charge is also 1 SU, and these two charges are separated by 1 centimeter. So these two charges Q1 and Q2 are said to be 1 SU if they are separated by a distance 1 centimeter. Force acting between these two charges 1 dyne. It means Q1 and Q2 are said to be 1 SU each if 1 dyne force is acting between Q1 and Q2 if they are separated by 1 centimeter. F is equal to 1 dyne, Q1 is equal to Q2, this is called 1 SU, distance between them is 1 centimeter. So now from Coulomb's law, F is equal to K Q1 Q2 by R square. So if we take the value, it is 1 dyne and K we don't know, Q1 is 1 and Q2 is also 1 and this is 1 square. So from there we get 1 is equal to K. So in CGS unit, value of K is 1. In CGS unit is equal to 1. So if we want to use Coulomb's law in CGS unit, we have the formula F is equal to K1 Q2 by R square. So F is equal to K we got 1. So it will be 1 into Q1 Q2 by R square. Therefore, F is equal to 1 2 by R square. So this is the formula in CGS unit. Now in SI unit, So SI unit of charge is Coulomb. There is a relation between SI unit and CGS unit of charge, and that relation is 1 Coulomb is equal to 3 into 10 to the power 9 ESU. This is the relation between SI unit of charge and CGS unit of charge. Now, how much force is acting between two charges of 1 Coulomb if they are separated by a distance of 1 meter? So let us consider two charges Q1 and Q2. Q1 is equal to Q2 is equal to 1 Coulomb, and they are separated by a distance 1 meter. How much force is acting in CGS unit? That is F is equal to 1 Q2 by R square. Value of Q1, that is 1 Coulomb into 1 Coulomb, it's 1 meter square. 3 into 10 to the power 9 ESU. This is also 3 into 10 to the power 9 ESU divided by, this is equal to 100 centimeter square. If we calculate its value, we will get 3 is 9 to 10 to the power 9 into 10 to the power 9, that will be 10 to the power 18 ES square. 10 to the power 2 and a square is there, so it will be 10 to the power 4 centimeter square. So this is the unit of force we written as dyne. So it is 9 into, this is 10 to the power 18 into, it will be 10 to the power 4, and this is dyne. And now force is equal to 9 into 10 to the power 14 dyne. If you recall the relation between Newton and dyne, as we know that 10 to the power 5 dyne is equal to 1 Newton. We can write here 9 into 10 to the power 9 into 10 to the power 5 dyne. Instead of 10 to the power 5 dyne, we can write Newton. So it is 9 into 10 to the power 9 Newton. The force between two charges of 1 Coulomb which are separated by distance 1 meter. We can define 1 Coulomb charge. Two identical charges are separated by a distance of 1 meter apart. Force acting between them is 9 into 10 to the power 9 Newton. From there we find the value of K. So let's find the value of K. Q1 is 1 Coulomb and Q2 is also 1 Coulomb, and the two charges are kept at a distance R is equal to 1 meter. Force between them we got 9 into 10 to the power 9 Newton. From Coulomb's law, F is equal to A Q2 by R square. 9 into 10 to the power 9 Newton is equal to K, and Q1 is 1 Coulomb, Q2 is also 1 Coulomb by 1 meter square. 9 into 10 to the power 9 Newton is equal to K. 1 into 1, that will be 1, and Coulomb into Coulomb, that will be Coulomb square, and here 1 meter square. K is equal to, here it will be 9 into 10 to the power 9 Newton, and it will be meter square and by Coulomb square. So that can be also written as 9 into 10 to the power 9 Newton meter square per Coulomb square. So this is the value of K in SI unit. In SI unit, we got the value of K is 9 into 10 to the power 9 Newton meter square per Coulomb square. Additionally, K is replaced by 1 by 4 pi epsilon naught. 4 pi because of spherical symmetry, and epsilon naught, this is the Greek letter, we read it as epsilon, and we put here 10 and we read it naught. So this is epsilon naught, and this represents the permittivity of free space. It is called permittivity of free space or permittivity of vacuum. So K is replaced by 1 by 4 pi epsilon naught, and its value is 9 into 10 to the power 9 Newton meter square per Coulomb square. Okay, from there we can find the value of epsilon also. So now our formula becomes F is equal to A Q1 Q2 by R square, and this one is equal to, instead of K we can write 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught 2 by R square. So this is the formula. F is equal to Q1 Q2 by 4 pi we use in SI unit. So from there we can find the unit of epsilon and value of epsilon. Let's find the value of epsilon, that is permittivity of free space. So let's find that value. 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9 Newton per square per Coulomb square. So from there we can find the value of epsilon. 4 pi epsilon naught is will be the 9 into 10 to the power 9 Newton meter square Coulomb square. 1 by 9 into 10 to the power 9 Newton meter square into Coulomb square. Epsilon naught is equal to 1 by 9 into 10 to the power 9 into 4 pi. 1 by 9 into 10 to the power 9 to 4, and its value is 22 by 7 meter square, and its value is 7. 7 will be in numerator. 9 into 10 to the power 9 into 4 Coulomb square per Newton per meter square. Naught is equal to 7 into 10 to the power minus 9 upon 9 into 4 per Newton per meter square. This value we will get approximately 8.85 or into 10 to the power minus 12 Coulomb square per Newton per meter square. So this is the value of epsilon naught. And now we will write the dimension of this epsilon naught. Unit of epsilon naught is equal to Coulomb square per Newton per meter square. So now we will write the dimension of epsilon naught. This is the dimension of Coulomb square into dimension of Newton into dimension of meter square. Dimension of Coulomb is A, B, and square is there, so we will write here square. So we will write the dimension of force M, L, E minus 2. Minus 1, power is there. Dimension of distance is L, and minus 2 is there, so we will write minus 2. So its dimension becomes A2, E2, M minus 1, L minus 1, E. It will be minus 2 into minus 1, that will be 2, and here L minus 2. So if we calculate it, it will be A2, T2 and 2, it will be T4, and L here minus 1 and minus L minus 3, minus A2, T2 and T2, that will be T to the power 4, and here L to the power minus 1 and L to the power minus 2, that becomes L to the power minus 3, here M to the power minus 1. So its dimension is M minus 1, L minus 3, T to the power 4, A to the power 2. So this is the dimension. Thanks for watching the video. If you have any question, go to the comment section and ask your question. Thank you.